Okay, so today we're going to learn dplyr. We're going to get into data wrangling. This is chapter 6. Just to put this in context, I really like this quote. This is an article in the New York Times, but it says that data scientists spend 50 to 80% of their time doing data preparation in order to actually explore their data in order to answer questions. Some of the common things that you'll be doing with your data are like removing columns or rows, or doing calculations, or adding new columns. Like kind of simple things or simple seeming ideas are part of what we call data wrangling. So I think of it as separately from data management or even data manipulation, which I don't actually know what, there's a lot of different words going on, but when we say data wrangling, we mean keeping the raw data raw, but then programmatically in R with the TidyVerse, wrangling columns and rows in order to get to the questions you want to answer. So we're going to introduce data wrangling in R using the TidyVerse. The idea of tidy data is what we're kind of striving for here. This is the idea that each variable is saved in its own column, and each observation is saved in its own row. So when we worked with ggplot last week, we were looking at the MPG data set, and this is an example of tidy data where if we think of it as like a cartoon, every column header is showing a variable, and then each row is a unique observation with information about a single observation. So like each outie has information going across the rows. We're going to be using dplyr to wrangle data sets like this. So this is kind of in the transform phase. And we'll be coming back later on today to actually work on getting data tidy in the first place, because a lot of data when you first get it into your computer is not tidy, and there's some work you need to do to make it tidy in order to start wrangling it to answer your questions. But we're going to be in this kind of wrangling, transforming part here. What's cool about this graphic, which this is the sort of data science workflow where you always start with importing your data, tidying it, transforming and visualizing it to communicate it. And what's cool is that there's this package, or this suite of R packages called the TidyVerse that are actually do these big steps. So there's packages to import your data, whether it's in Excel or CSVs or from a database or from PDFs or from images. Like there's different ways to import them. And so we're tidying and transforming. And so we're going to be in this transforming period today using dplyr mostly. All these packages that are written on this graphic are all packages that are part of the TidyVerse suite of packages. Go into our studio session you've got going, synced with GitHub, and we're going to create a new our Markdown file to work on today. Again, we'll go up to this new, you can go to File or go to this little green button and say New R Markdown. So I'm going to save this as, I'm going to call it Gapminder Wrangle. You can name it whatever you want. And then I'm going to delete everything else here. So we're going to wrangle Gapminder data using dplyr. I'm going to write a little note to myself. First thing we're going to do is load this package that we're going to be using. So I'm going to insert an R code chunk here and load my library, which is the TidyVerse. So when I run library TidyVerse, it gives me a bunch of information about all of the packages that are within the TidyVerse package. And it will tell me that there are a few conflicts where some of the functions within dplyr will be the default ones that R will use instead of what base R had because there's the same name, and that's all fine. It's also going to give me some warning messages, which is fine. If you do not see this, if you see an error that says that you don't have TidyVerse installed, what you can type is install packages and then quote TidyVerse. So I'm not going to run this since I already have it installed, but what I will do is I'm going to put it as a little comment next to the library so that in the future, if somebody tried to run this and they got an error, they would immediately know how to install what they needed. Another way you could install a package is going over here to packages and going to install and then typing TidyVerse, and it will pop up and let you install it. So there's multiple ways to do that. The data that we're going to be using is on GitHub right now, and I'm going to want you guys to copy a URL. You can either copy this URL by coming down to the book and copying it right here from section 6.3. You can also navigate to it from github.com. If you go to github.com/OHI-Science, and then if you go to the data science training, and then to the data folder, and then to the gapminder.csv. So we just wanted to have a look at the data first. Sometimes it's nice to look at it before you get it into R. But you can see that this is a pretty tidy data set by our definition. So there's each column has is a separate variable, and then each row across is a unique observation of a single country in a single year. And then looking at the variables by population, continent, life expectancy, and then GDP per capita. I want you to copy this URL, but it's not going to work if we copy it just from this URL. We actually want the raw CSV data. So if you click on this raw button, you'll see a different view of that Gapminder data. It's in a more familiar CSV format. It's not rendered nicely the way GitHub had done. So let's copy this URL here. And then we'll go back to our RStudio session. We can read in data from a URL, which is pretty nice to be able to do. And we can do this by, let's assign it the variable Gapminder. Let's call it Gapminder. And we're going to use the read CSV function. It's actually from readr, which is one of the packages in the TidyVerse. And we can have within quotes, we can just paste that whole URL that we had copied, this raw.github user content, gapminder.csv file. If you go ahead and run this line of code, this reading in this Gapminder object, oops, I'm gonna go ahead and escape this away. But you can see that when I use read CSV, it's gonna give me some information about the data that it's just read in. So it's gonna tell me that it read in these columns, which sound familiar to us since we just looked at it on github.com. And it actually is guessing about whether it's a word like Afghanistan or Africa, or whether it's a number like 1981 or 2000 or something. So this is just basically what this is telling me is not an error. It's not a warning. It's just trying to give me some information about the data it's just read in. Let's have a look at what the Gapminder data set looks like. And so sometimes when I just explore, I might do this in the console or in our Markdown file, but we'll go ahead and do it in our Markdown file. I'll put this I might start this in a new chunk where I'm actually like exploring my data. Explore the data. I'm gonna say, we're gonna use our head function to say head Gapminder and have a look at what the data look like. So if I run this, you can see in the console, this looks good, right? It looks like the data was read in correctly. This looks pretty similar to what we were just looking at online. Just to make sure that it's not just these first 6 lines that are looking good, I also like to look at tail just to make sure there's nothing weird going on at the end. You can see that all the way to Zimbabwe in 2007, things are looking pretty good. These 2 functions are really helpful. They, by default, will show you 6 rows of anything, but you can also specify more information if you want. So you could also say head Gapminder. You could say that you want to see 10 rows, and that will return 10 rows for you, so you're able to see more information. So those are just handy functions to just start to explore your data set. Another set of commands that I use to just explore data from the beginning is to look at the structure of the data, and that's a function called str. So if we look at the str of Gapminder, so if we look at the structure of Gapminder, you'll see that it's going to give you different information about your data frame. So you can see that it's 1,704 observations of 6 variables, which, that sounds about right. We hadn't actually looked at how big this, or what the shape of this data frame was before. So now we know that it's 1,704 by 6. And then again, you can see it's going to tell you all the different columns that you see, and also, again, give you information about whether it's like a character, which means a word, like Afghanistan, or whether it's an integer or a number that you'll be able to do math on. We're not going to get into the different types of, character versus integer versus number, but I do want to point that out, because one of the most common errors you might get when you're reading in different data is if you're trying to do math on numbers, but R actually thinks that it's a word. And so it's going to give you errors that you don't understand. One of the quick checks you can do is to look at the structure and see, like, oh, right, year is an actual number that we can work on, as opposed to it being something that is surprising. We can also see some of this information if we go back over to the environment pane. Actually, when I read in data, I like to have this environment pane open, because I can also, as soon as we read in Gapminder, we could see immediately that it was 1,704 by 6, which, sounds right. It's not like there's only one column, or, there's little cues that you can look into to see if information has been read in right. Another thing that's written here in the structure output is that this is the Gapminder object is a data frame. There's also things called matrices or arrays. We're not going to talk about them very much, but a data frame is becoming a pretty standard thing in R, and especially with the TidyVerse. Like, most functions and packages will expect your data to be in a data frame. And so when we use TidyVerse packages to read in data, they're by default a data frame, which is great. What's really awesome about data frames is that you can have both numbers and words in a single place. Before, you had to have them in separate objects and then always be uniting them. So yeah, that's one of the powerful things about data frames. There's a new thing called a tibble. It's like the next generation of data frames. Tibbles will also let you have things like other data frames in there, or you can save ggplot images in there. So it's like it almost makes it multi-dimensional. You can store lists in there. We can look at some other information about our data frame. So we can look at the column names, which is sometimes useful if, right now we only have 6, but if you ever had a lot more, it's nice to be able to just look at the names of what the column headers are. We can say names of Gapminder, and this will return each of them as a string. And so if you ever needed to capture the names of your columns, this is a quick way to capture that information. Even though we can see that the dimensions of our data frame is 1,704 by 6, and we also saw that in the structure output. If we ever wanted that information in R, there's a command called dim that will give you the dimensions that you could then operate on. So that's actually pretty handy sometimes if you wanted to take like the last number and you don't know how long it is. Having a dim return 1,704 might be nice. And also there's a function called ncall. So if we look at this means the number of columns. So if we run that, we'll see that there's 6 columns. And then nrow. Yep. So you can also look at those numbers separately. So one of the reasons I showed you both dim and ncall and nrow, which are, getting at the same information in different ways, is I wanted to show you that we can actually, let's create what dim returns from ncall and nrow. So I'll show you what I'm talking about. So there's a function called C, which is, you know, kind of an unfortunate name for a function, because you might want to write that as your variable name someday. So in R, you shouldn't use C as a variable name, but there's a function called C. We can actually look it up, and it combines values in a vector or a list. So if we said C of n row of gapminder, and then n call of gapminder, I'll put spaces here so you can kind of see what I'm doing here. So I'm putting n row is 1704, and then n call, which is 6. And if I put this together within this combining function and I run this, I'll be able to create the dimension again. So this is a way to combine information that can also be within a function call. And we'll use this C function quite a bit later on, so I wanted to introduce it here. If we want to see what type of thing this gives back, we could actually assign it to a variable. So let's just call it x for a second. And then we'd be able to see that x is, we could look at the structure of x, and it's just an integer. It's a little vector string. This is like exploring the whole, or the data frame as a whole. Let's look at some summary statistics, because that's another thing that is good to check out right when you read in data. So there's a function called summary, which will give you, for every single column, it will give you a summary. So when it's not numeric, it will just give you how long it is and what the class is. But then for each numeric variable, it will give the min, median, max, and quartiles. So it's a way to check it out. They'll also tell you if there's NAs in it. This is a way to just like at a glance see that, like, oh great, my data do go to 2007. And you know, you can also see, like, at a glance, like, wow, there's a life expectancy in here of 23 years old. Like, that's pretty low. And you can see the huge range of GDP per capita as well. So you can just have a look at statistics really quickly. So something too, that this is a new package that is pretty useful for looking at summary statistics. It's called Skimmer. I don't know if we can load this library really quickly. You'll have to install it, SKIMR. And I'll write, it's install packages skimmer. But what's cool in this package, there's a bunch of different things here, but one of the things that's cool is if you skim Gapminder, it will give you a different way of looking at summary statistics. It will give you different information by type. First, we'll show you, again, the dimensions, 1704 by 6. It will give you these character summaries. And what's nice is that it will show you how many unique entries there are. So there's 5 continents in this data frame, and there's 142 separate countries, which is cool. That's something we haven't learned yet, based on what we've looked at before. And then what's also cool is that for numeric or integers, it will show you if there's any missing data. So if there's any NAs, that's also really nice to look at a glance. It will show you mean, standard deviation, quartiles, and then it will also show you a cool little spark graph histogram of the distribution of the data, so you can see if it's normally distributed or not. And something that also makes this package super powerful, it plays really nicely with other TidyVerse stuff that we'll learn along the road. Now I want to explore inside the data frame. So I'm going to insert a new chunk here. One of the ways that you can specify a single variable within a data frame is to use the $sign syntax. So this is something in base R where if you say Gapminder and then you put a $sign, you can actually put a single column name here. And our studio, you can see, is as soon as I type the $sign, it's prompting me with my options. If I said I wanted life expectancy, I could either select it here or type it out and hit tab. And if I just look at, if I run this, it will just give me information from that single column. You can see that it's kind of a lot to look at a glance. That's not exactly what, it's not the most useful thing for me just to have a quick look at it. So this is also where you can use what we just learned. I'm gonna copy this and paste it down here. And you can look, you can use head, you can use those other functions we just learned on a single column. And here, yeah, you can see that this isn't in our nice data frame structure right now. This is outputting, again, as one of those little integer lists or integer vectors. You can also, what we learned before, you can also use structure on this gapminder $ life expectancy. And so you can get the same information. You can see that it's numeric and you can see how long it is, but I find it more useful to do that kind of, to ask these kinds of questions about the structure and what the head looks like from within the full data frame, if possible. Let's get into data wrangling with dplyr. So I'm going to switch back to the book for a second because there's some graphics that are included in some of RStudio's cheat sheets that I think are really powerful at describing what we're going to do. Because our data is in this nice data frame, there's times where we are going to isolate observations by their values, and that's going to be in our filter. It's going to be with the filter command. So this would be if you wanted to select only Afghanistan, you'd be able to filter for Afghanistan. So that's selecting all the observations across rows. And then there's also times where you want to select based on variables themselves. So in the dplyr language, that's called select. So I think this is really powerful that these are like concepts that you'll want to do. And then there's not only words to describe what you're doing, but then there's a function that will do them for you. So filtering is by rows, selecting is by columns. If you want to add a new column, it's called mutate. And then if you want to summarize data and actually sort of collapse rows into a single value, like if you wanted to find the mean of Afghanistan, that would be a summarize function. So we're going to go through each of these for the rest of this lesson. And all of these can be used. You can also group data before you do these operations, and we'll do that too. All of these verbs, I think of them as verbs, they all work very similarly from a programmatic standpoint. For each of them, the first argument will always be what data you're using. So, you know, for us, gapminder will always be the first thing that is within any of these functions. And then the other arguments will describe what we're going to do to the data frame. And you're going to be able to refer to columns without the $ syntax. This is like a sort of big picture reason why this is important, and you can come back to it after we've played around with it a bit more. And the result of these verbs is always going to be a data frame. Okay, and then we'll also be chaining these things together, and I'll show you because that is super, super fun. And I want also to say that this link here from the book is for this whole cheat sheet for data wrangling in dplyr and TidyVerse, and this will be a great reference to you all as you go further. I think like showing visually what you're trying to do with data and then showing the verbs that go along with it is super powerful. We'll be starting off with filtering, which is going to be removing, isolating rows. So let's go back to RStudio and use dplyr. So I'm going to insert a new R script. Let's say filter. And you can see, since we've got the TidyVerse loaded, RStudio is going to help prompt what I might want to say in my filter function, but I'm going to say gapminder. And let's say we want to filter the gapminder data and look at where life expectancy is less than 29 years old. So this syntax of filtering our data set on a single column based on some kind of criteria is will result in this output here in the console, which is a data frame. So you can say this out loud. You can say, I want to filter the Gapminder data for life expectancy less than 29 years old. And you can see that, yeah, it's just returning 2 rows of data that meet these criteria, which is good that there's not more. So that's one example. Let's try another example. Let's say filter Gapminder. And here, let's say where the country is equal to, let's say, Mexico. So here, if we run that line of code, we'll get 12 rows of data back, rows of our data frame. These are all of the instances in our data frame where Mexico is the country. So what if you wanted to do multiple countries? What if you wanted to do Mexico and, what's another country you guys want? Mexico and Chile. You won't actually be able to do that double equal sign anymore, but we can use a different operator called an in operator. So here we can say filter Gapminder country, and here we say in, and then we can use that C command that we just learned, and within here say Mexico and Chile, and then make sure that we've closed all of our brackets. Okay, so if I run that, you'll see it's not actually going to print out everything that I've requested, but we could set this as just a temporary variable called x if we wanted to, and then go over here to our environment and check out what x looks like if we just wanted to have a quick check. Let's see, how about if we wanted to look at Mexico in a specific year? We could do that by filter one country in a specific year. We could say filter Gapminder, and then we could say country equals Mexico and year equals 2002. And that will, as we expected, just return 1 row. But if you're ever concerned that there's duplicates in your data or something, that would be a quick way to check. So that's kind of the basics of filter. Let's learn select now. So selecting is by columns. Let's see, filtering. Filter by rows and select by columns. Okay, to show this, here we're going to isolate specific columns. So we use select. So again, we say select, and the first thing we say is Gapminder. And then we're able to say, let's keep the year column and the life expectancy column. And if we run that, you'll see that now we have a data frame, a tibble, that is just 2 columns because that's all we asked for. We said select just those 2 year and life expectancy columns. What's cool is that you can also use the minus to deselect columns too. So let's see what that looks like. This is if you would want to say select, you could say select Gapminder. And let's say you don't want the continent column, and you also don't want the life expectancy column. So if you run this, oh, I've got a nice typo in here, continent. That looks better. Oh yeah, so but that's what this error is saying, that the object, this thing, is not found, and that means the first thing I look for is a typo. But if I run this, then we would expect to get all of the columns back that are not continent and not life expectancy. So that's a nice way if you've got a lot of different columns and you don't want to type them all out, which you probably shouldn't. You can just deselect all the columns there. That's sort of the basics of select. Let's say we want to filter the country for Cambodia and then remove the continent and life expectancy columns. And we'll save this as a temporary variable. So I'm going to call my variable gap Cambodia. How will I use, what will I say for my filter statement? Gapminder. Country. Cambodia. Cool. Awesome. If I run gap Cambodia, then I can just have a quick look at it. It's going to be these 12 rows across these 6 columns, which is great. And then if I want to select the columns that are not continent and life expectancy, I'm actually going to save another variable called gap Cambodia. Maybe I'll call it Cambodia 2. You could also overwrite gap Cambodia itself, but to do this in 2 steps, you'll have to call it something. I'm going to call it gap Cambodia 2, and then I'm going to say select. And here, what am I going to be selecting on exactly? So I'm not going to select on the Gapminder data frame because I don't want all of them. I don't want all of the countries. I only want the Cambodia country. So if I say select gap Cambodia and then I subtract continent, and I can spell it, deselect continent and also deselect life expect. So if I do this now, let's see, I've got the second gap Cambodia column that I can see has 2 fewer variables than the original. So even though I can't read these, I can guess which one I want to look at. And when I click on it, then I can see the full name. So this is great. This is now 12 rows of Cambodia data without the continent and life expectancy columns, which is great. Life-changing pipe operator, which looks like this. It looks like % greater than sign %. And there's actually a keyboard shortcut for that as well, which is Option-Shift-M. Let's have a look at what this thing is. Let me demo what it does instead of trying to explain it. Something I can do here is I can say Gapminder, and then I can use this pipe operator and say head. The shortcut, Shift-Command-M. And you could also find that. It's also in the keyboard shortcuts help, insert pipe operator. So if you're on a Windows, it will tell you what the shortcut is. I'm going to delete all of that. So, okay, so let's look at what Gapminder pipe head means. So this is going to do what we looked at earlier, which was, this is equivalent to head of Gapminder, right? If I ran head Gapminder, this is giving me the same thing. So what this is saying is it's allowing me to say the data I'm going to start with and then what I want to do to it. So take the Gapminder data and then return the head 6 entries of this data frame. So this pipe operator you can actually use to read like the story of your data analysis, and the way you pronounce this is by saying and then. So take the Gapminder data and then take the head of that data. You can still pass other information to this function too. So if I wanted just the first 3 rows, you could say Gapminder, take the Gapminder data, and then give me the head of just the first 3 rows. So if I do this, I'll now just get the first 3 rows. So you can see that this is this is now, this is equivalent to head of gapminder, comma 3. But you can see, so you can see that when I pipe something, I don't need to say the data I'm working with anymore, because the data is like announced up front first before you do anything to it. So it's actually a really powerful way to be able to write and read code, is to know immediately the data you're working with. Let's go back to our Cambodia data. I'm gonna copy this down below just so we can check out how we could rewrite this stuff using the pipe. So I'm gonna bring this back down here, and I'm now, okay. Now let's do that with the pipe operator. We're gonna say gap Cambodia, and we can assign that to, you know, we're gonna say, we're gonna take the gapminder data and then filter by country equals Cambodia. Okay. And so this, if I run this, this will give me this gap Cambodia variable again, which we didn't expect to change, and it looks like it hasn't changed. And then let's do one more. Let's do the second one. Let's say gap Cambodia 2. It's the gap Cambodia data, gap Cambodia, and then select, and we'll just go ahead and say minus continent, minus life expect. So you can see this is the way we would rewrite what we saw above, which, like, it's a little, you know, to me, it reads more cleanly because I can see the data up front instead of having to look within a function to see it. But you can see that this is still, you know, the same lines of code, and we still have these two temporary variables. So that's actually not, we're not that much better off. But what's the most amazing and convenient thing about these pipe operators is that you can use them to chain between these two statements. So if we could say, I'm going to just copy this again just to leave a record of what I've done, but you're welcome to just change what you've got there. Since this, the output of this statement is what I want to start off with here, I can actually delete all of this stuff and just pipe that first statement directly into select. You see what I did? So I actually deleted temporary variable 2, which was going to read in this temporary variable 1, and I was able to just pipe it directly in there. So I can actually, to make this more readable, I can also put some returns in here so that this can read more like a clearer story. So what's happening here is I'm making a variable called gap Cambodia, which is the gapminder data, and then filtered by the country of Cambodia, and then selected without these columns. And then also the way that this can sort of read as a story, to me, I think is super powerful, that you can, instead of having to read through this and trying to think about what this means together, you can see it at once there. So if I run this line of code, these lines of code now, and keep an eye up here, if I run this, you'll see that that makes this gap Cambodia variable actually only have those 4 columns because it's done those 2 operations together. Let's learn about how to add variables using Mutate. Variables using Mutate. I'm not going to push it, but I might just commit this so that I can say, like, dplyr, I'm going to say up to the pipe operator, just to have like a little record to myself, but I'm not going to push it right now. Again, just visually, what we're going to be doing here with Mutate is we're going to take our data frame and we're going to add another column to it using this Mutate function. So And we'll do this from the start using the pipe operator. Let's go back to our Gapminder, our full Gapminder data frame. And then mutate a column. And you can see that after I've typed the pipe operator, I actually hit return just to kind of, you can keep all this stuff on a single line, but I like to be able to see the verbs sort of quickly so I can skim and see what's happening. So I'm going to say mutate. Let's just add a new column that will be 1704. Just let's say we wanted to number our columns. So we could just say, let's call this new, let's give this new column a name. Let's call it index. And let's say it should be 1 to the length of Gapminder. So we can say 1 of n row. So this is kind of Gapminder. So this is kind of using what we've learned so far. If we run this, it will just give us a little display here in the console. You'll see that now we've got this new column called index, and it goes from 1 to 1704 if we looked at the whole thing. But what's cool too, one of the reasons why I wanted to show this is that there's a couple different things going on within, like this new column that we created actually used other functions within it. So we used our nrow function to operate on Gapminder within our mutate function. So you can do other operations within a mutate function, and they don't have to be TidyVerse functions, which is pretty powerful. Let's do another example. Let's say Gapminder, and then let's mutate a column that's actually let's calculate the GDP. So let's have a column, let's name it GDP, and we can make it equal the population column that we have already times the GDP per cap column. So this is going to operate on the columns that are within the data frame already. So if I run this, you'll see that now I've got a new column called GDP that is I was able to multiply basically across the rows for population and life expectancy and create unique values for every single row in my data frame. And it's nice too that since I've already announced that I'm using the Gapminder data, again, I can call the column name here without having to remind anybody or remind R that it's from Gapminder. So just to show why that's important is if I came into my console and tried to write pop, nope, not that, I just want pop, it would tell me it doesn't exist because it's actually not a standalone object, right? I don't see it up here anywhere. It's not a standalone thing. It's actually a column within my Gapminder data frame. So when I've already announced that we're working within Gapminder, I'm allowed to just name it by column name. So Gapminder, and then
would you mutate? Maybe call it max GDP.
Okay, that's a good name.
Equals, and then maybe you do max, use the max function. I guess we had to filter for just Egypt and Vietnam first.
Okay, yeah, because if we take if we continue here, we'll actually get the max of every single country. But what's cool is that this, I'm gonna kind of leave this where we were, and I'm gonna add a new row above it, right? Because just logically, we need something else before we mutate. So what should we do first? We want to filter. Yep, so we want to isolate Egypt, and Vietnam, and then we want to find max GDP per cap. Cool, let's have a look. Whoop, not like that, sorry. So yeah, when I do this, I'm gonna get, let's see, I might just save it as a little temporary thing just so we can look at it again. I'm gonna call it X again, just so yeah, look, this is now 24 by 7. So we've added the 7th column of max GDP, and we've got just Egypt and Vietnam. This is great. And this is giving us the max GDP of these 2 countries together, right? So this, and it's repeated because maximum, there's only one number that is going to be the maximum of this GDP per cap column. And so when you mutate a column and just give it a single value, it will repeat it for the entire length of the column. If we wanted it to be the maximum of Egypt and the maximum of Vietnam, we would need a new verb in the TidyVerse, called group by. You don't want to just do the entire data frame. You want to group first by, in this case, like teal or green, in order to then mutate a column. So that's what we'll do. Let's say we want to change this to give us a maximum GDP of both Vietnam and of Egypt. I'm going to copy this just to keep a record of it as we go forward. Let me write a little note. So find the max of both Egypt and Vietnam. And then if we wanted to find the max of, I'm going to say together, and then this is the max of Egypt and Vietnam separately. What we would want is, before we do this calculation of max GDP, we're going to want to group by Egypt separately from Vietnam, is essentially what we're going to do. So we still want this same kind of storyline where we say data and then filter and then mutate, but we also want to, before we mutate, we want to stick in a new thought, like a new operation. So we're going to say we want to group by, which is this new verb in TidyVerse, Egypt and Vietnam. How do you think we'll tell group by what we want to group it by country? Yep. So we can just tell them the column name. We can say group by country and then mutate. So we've just added a single line here. And if I run this now and we inspect X again over here, you'll see that it's going to repeat this maximum GDP, oops, in this column for Egypt, and then there's going to be a separate value that's repeated all the time for Vietnam. Before we added this line here, I'll name these things differently so we can look at them. So before, when we just had X without this group by, it was going to take the maximum GDP of all 24 rows. And we said, okay, but that's actually not really what we want. That's not really our question, is we really wanted to be able to differentiate between these two. So then we were able to say group it by country first and then give me that maximum value. We put this group by variable, here in our storyline. We said gapminder and then filter and then group by and then mutate. It would have worked just as well before the filter statement if we said group by country and then filter by country. Let's have a look. That will give us the same thing that we expect. So as long as the grouping by happens before the mutate, that will give us what we want. Here we're grouping by every single country, all 142 countries. So it's doing that operation on all of those countries before we filter just for Egypt and Vietnam. And so in this data set where it's rather small, that doesn't take any analytical energy from R to really do that. But you can imagine if it was a huge data set, it might save you time to keep it after the filter statement so that you've already minimized the data you're working with before you group by. But sort of logically, in terms of what you want to do, it's fine to put them in either place. Group by is super powerful, and actually let's have a look at the structure of X2 now. And if we look at this thing, you can see that we've seen all this kind of information before, country, year, but this is super important to point out to you guys, is that now this object x2 is a grouped data frame. If we wanted to act on just a single row in our data frame, it would give us errors because it's still considering Egypt together and Vietnam together because we've grouped them. So something will keep you safe if you use a group by command is to always end the statement with an ungroup. So it's still just a single data frame, but every row is not independent anymore. Like it's still considered a unit with Egypt right now. There's a lot of times that might not matter. Like this is the end of our little analysis, and so we're not going to do anything more with our x2 variable. Maybe that's fine, but we've definitely run into problems where 15, 20 lines down in your analysis, you're trying to like take a maximum of something or a mean, and it's just like it's not what you expect, and it's because it's still clustering the data together. So we have started, whenever we use a group by variable, we always use an ungroup at the end, and it's another thing that you say, and then ungroup your data again. And so now if we look at the structure of x2, you'll see that it's what we expect. It's the data frame, and it doesn't say groups. It's important to remember to ungroup. I should have an example of if we tried to keep operating on a grouped variable and didn't expect it, because it won't necessarily give you an error, because it might not be an error. It'll be a silent thing that's happening that's not what you expect. There's times when you're going to want this maximum GDP value repeated for every single row, because maybe that, now you're going to do some kind of continued operation, like let's say you're going to model it with life expectancy. And so it's nice to have this repeated value kind of in a row so that you can operate row-wise across all your calculations. But there's also sometimes where you're like, actually, all I want is that number. I don't need it 12 times. I just want to know this, a quick glance of what the summary data is. And so one of our last verbs that we'll learn today is a verb summarize, which is actually going to collapse your data. So when you start with the data frame like this, you'll collapse it into a single value. And this is really powerful to use along with group by, because you can collapse those values into information based on the group. So let's have a look at this. We go back to RStudio. Let's say summarize and group by together. Let's start again where we say Gapminder. And then let's mutate a column. We'll call it GDP. And again, we'll have this be pop multiplied by GDP per cap. And then let's summarize. Let's use this summarize function. Oops, I've forgotten to, well, we'll add it in a second. Summarize max GDP equals the max of GDP. Oops, GDP. Okay, so let's try running this. I've forgotten my group by function, and I'm just curious what this will look like if we run this all without a group by. So if I run this, I'm going to get a single number back. Of all 1,704 rows, this is the maximum GDP. That's cool, but we actually wanted it for every single country. So let's add a group by statement. So I'm going to start off by here adding a group by country. And then I'm also at the same, oops, I've got a, well, I'll show you that error in a second. If I tried to run this right now I've forgotten my pipe operator. If I tried to run this, it would give me this error. It will say mutate GDP per cap does not, like the object pop is not found. So this is, you're like, wait a minute, I know pop is inside Gapminder. Why is this saying me that pop isn't found? And what I sometimes find helpful if I didn't immediately see that this is missing a chain, and so this seems like a standalone statement that has nothing to do with Gapminder. If I didn't immediately see that, something I like to do is you can have RStudio indent your lines based on what's going on. And this would put mutate, you can immediately see that mutate is not part of your chain. And so that would actually help me see that, oh, I've missed a pipe operator. So if I put that there, if I add it, now I can go and re-indent my lines. And the shortcut on a Mac is Command I. I use this all the time. Now if I do Command I, now they line up again so that I can visually see that this is all working again. And now if I run it, this will give me the output that I want, which is this immediately looks right to me, where there's 142 rows, because I remember that there's 142 unique countries, and there's the information I have is by each country I've got a single value of max GDP. When we mutated the max column, we would have still had the whole 1704 rows, but we've collapsed it into just a unique row. Okay, so since I've got a group by in this statement, I'm gonna just always add an ungroup so that whatever happens next, this is a good practice to keep. So I'm gonna go ahead and add an ungroup so that this will be nice and tidy for me later. Right now we haven't saved it in a variable yet. We could save it in a variable if we wanted to, but actually what I want to know right now is who has the highest, what's the max GDP here. And so what we want to do is sort, you could sort this column from min to max. There's the verb for sort in the TidyVerse, and we can just append it here with another pipe, it's called arrange. So we're going to arrange, and we have to tell it what we want to arrange by. We could either arrange by, right now it's arranged by country. That's why it's in alphabetical order. But we're going to arrange it by max GDP. So if I run this now, it's going to return information that's not, it doesn't start off with Afghanistan yet. So this is going to arrange in ascending order, which means the smallest is first, and then the highest GDP is at the end. The default is from min to max. If we want it the other way, there's got to be a way for arrange to let us do that. So let's have a look in the help. We can just have a look at, we can expect that there's a way to make this flip. So if we say, look at arrange, the help menu says, okay, well, there's actually 2 packages that you have loaded. Well, for me, there's 2 packages I have with this function called arrange. You need to choose which one you want. And so I'm going to say, I want the one from dplyr. So I'm going to click on it. And then look, the first thing it says is use DESC, which is short for descending, if I wanted it in descending order. So I can go over here to my arrange variable and say des, and then add a parentheses. Actually, I'm gonna do that one more time, and just because there's keyboard shortcuts that I use a lot that might be useful for you. So I'm gonna do Command Z a couple times just to get me back here. Knowing that I want to write something here, I write DESC. And then a parenthesis, and now I want to go to the end of the row. I can say command right arrow, which will take me to the end of the line. So that's how I jump over there really quickly to close my second parenthesis. What would we do within this workflow to identify countries in Asia? I'll copy this down here so we can work on it together. And I'm gonna say, I've got a couple hints. We can use, okay, well, we know this already. We can use the max function and dplyr arrange, which I guess we've already used. So yeah, we'll add a filter continent equals Asia. Okay, so if we run this, now this will isolate the countries in Asia. I might actually save this as a temporary variable here, so we can have a look at it in the environment viewer, which I like to do. So now this is a way to look at the countries in Asia. So I think what's cool about that is that you've got this storyline that you've got in your mind of taking the Gapminder data and grouping by and mutating and summarizing. And if there's something else you want to do, if you want to say, oh, I only want to look at Asia, you can add that line within our sort of storyline and build this story of the data wrangling sort of iteratively. We didn't necessarily think of that all at the same time, but we were able to, in a non-linear way, I guess, stick this operation into the beginning of our work in order to move forward. I like that a lot about the TidyVerse and piping, is that you can build the analysis you're doing kind of iteratively and add things in above. I'm gonna just take a minute and go back to the book here, where just to show you a couple things. This is essentially everything we learned today in a nice, tight analysis. And just to, in R, because it's a language, right? And there's there's different ways of saying the same thing in R. It's just the way you can think about that in English or in any other language. So this is the TidyVerse way of doing the analysis that we've done. But you could also do this in base R. And if we had done this in base R without the TidyVerse, we could have achieved the same thing. But this, to me, is not as readable as what we just did with the TidyVerse, because this uses this kind of bracket, comma syntax to extract rows and columns. And it uses a lot of temporary variables and $ variables in order to sort of achieve, in this case, it was trying to find the max GDP of Mexico in the end. So you'll definitely see code like this, because this is R. This is the way R has been written for most of its existence, but we've really moved towards the TidyVerse because you're able to not only see what data you're starting with and then immediately see the operations that were performed on it. So it's more readable to you and it's more readable to others. And since we're really into collaborative coding and team science, like we want like sort of shared practices. So that's why we use all this stuff. Let's talk about joining data sets, because oftentimes the information you want to analyze and the questions you want to answer are not all in a single data frame to begin with. You actually, they might come from different databases, from different CSV files, from different whatever, and you want to get them together into the same data frame so that you can operate on them, like calculating the GDP or whatever, right? But they might not be in the same data frame to begin with. So this is called a couple different things. It's called relational data, combining data, or in the TidyVerse language, we talk about joining data sets. And I really like, again, these images from the cheat sheets. There's different ways that you might actually want to join data. So let's look at this example where you actually, let's say this is data from like a temperature logger, and this is data from my observations in the field, and you want them to be together. So there might be similarities between some of the data. You can see in this has a column X1 and this has a column X1. And there might be observations that are similar, A, B, C, but also A, B, D. And then there might actually be columns that don't match. And so you might want to join these data based on this X1 column, let's say. So if you wanted to combine these two tables, how would you do it? You have to make some decisions about what's important to you and what you want to keep in order to combine these data sets. But there's, like, rest assured that there's a way to do it, and there's a TidyVerse verb to do it. When you add these two data frames together, you might want to keep all of the information from one of the tables. So you might want to keep all of the observations in this X1 column, A, B, and C, and that would be at the cost of introducing an NA value where there wasn't a match in this X3 table, right? Because there isn't a C row. So it kind of takes a little bit of time to think about this stuff. I definitely study this thing each time I do a join, just to make sure I know what I want to do next. But so in this case, you would say, I want to keep all the information in this one column at the cost of having some NAs in this column. And for that, this is going to be called a left join, because the way you kind of conceptually think about these two tables is there's a table on the left and there's a table on the right that are going to become a joined table. And so if it's a left join, you're going to be, you want to keep all the information from this X1 data table on a left join. Similarly, on a right join, you can still think of the data as this left and right. And in this case, you'd want to keep all of the information from the right table. So this A, B, D. And that's at the cost of losing some information for this D variable because it didn't exist in this column to begin with. You know, left and right joins are kind of interchangeable because you could also read in the data oppositely. You know, a left join where you say left join A is on the left, B is on the right, is the same thing as a right join where you say B is on the right, A is on the left, but you can know that there's these two options that you can do. There's also times though where you only want to keep information that's similar across the two tables. So this inner join will only keep the information that shows up in both tables. So you can see that this happens at the cost of actually losing data in some ways, because you lose the information that came with C in this table and the information that came with D in this table. But that might be fine because maybe you only want information where you keep those data. And then there's also an option of full join where you say, I want to keep everything. And yes, that's going to give me NAs in a lot of places, but that's what I want. And obviously, in any of these cases, once you join these tables, you'll still be able to use all of the data wrangling stuff we've learned this morning. So even if you choose full join, that might be what you want to see at first, but then you might want to filter out every single row that has an NA, which would then get you here in a second step. But maybe you want to see those NAs before you move on. So they're pretty powerful functions to join data, but it does kind of make you, there is some thinking and choices that you make in terms of which one you use. Let's play around with this a little bit. Let's read in a new data set, which is going to be in the data folder, or you can copy it from right here. So let's see. If I open up a new tab, I would go to github.com/OHI-Science, and then I'd navigate to this data science training, to my data folder, and then it's going to be called co2.csv. And this is what the data looks like. So we're going to have country data and CO2 in 2007. Let's say that this is just a little snippet of a real data set that I took, and I think I've got where it came from in the notes. But this is what we're going to be dealing with. So we've got this subset of countries with some CO2 data that we're going to join to our Gapminder data because we want to know the CO2 emissions based on GDP, let's say. So click on this raw button in order to capture this URL so that you can read in the CSV directly. What we'll do is let's first read in the data. So read in CO2 data. I'm going to call it in a variable called CO2. And I'm going to assign this to, I'm going to say read_CSV and paste in that URL. Run that and just have a little look. Country is a character column, which sounds about right. And then the CO2 values looks like it's numeric, which is what we want. We can have just a little tiny peek further just to make sure it all loaded in correctly. So I'm going to say CO2 and then head just to have a look. That seems right. This looks like what we'd seen on github.com. We know that this is 2007 data for the CO2. So let's create a variable called gap 2007, just so that we start with a smaller data frame when we keep moving forward. So I'm going to say, let's name a variable called gap_2007 and assign that to Gapminder, like take the Gapminder data and then filter for the year 2007. Okay. So I can run that, and I just check in my environment pane at a glance. It's 142 by 6, which, you know, that sounds really right to me because I know there's 142 countries. Just a little check. Let's try left joining. Left join. Let's join gap 2007 to the CO2 variable. So that's going to look like, let's call it, I'm going to call mine LJ for left join, just as a little temporary name. Say LJ is, I can use this left join function, and we're going to say gap 2007, comma, CO2. And I'm also going to tell it which column I want to join it by. So I'm going to say by equals country. So if I run this, now I've got this LJ object that I'm going to look at here. You can see that this has added a new column for me called CO2 2007, and it's joined Afghanistan, you know, it's joined data where it's available, and the rest are NAs. So it almost, you can think of it as like it's mutating a new column based on the other data frame. But it did the work of finding Afghanistan in each data set. There's a bunch of different ways that we could explore this, but let's have a look. Explore LJ. So we can, you know, look at the dimensions, which we just saw. It's 142 by 7. I guess we just saw the summary of this too. Since we looked in the summary column or the summary function, you can see that there's quite a few NAs here. There's 135 NAs in this join. So, you know, I want to know more about how this is joining and what might have been missed, because remember, CO2 had 12 observations, 12 rows, and I don't think that all of those are reflected here. It looks like there's only, at a glance, it looks like there's only 7 that matched. So there's some that didn't match. So if we right join gap 2007 and CO2, then, and I'm going to call this variable RJ for right join. So if I say right join gap 2007, comma CO2 by equals country, if I run this and have a look at this, so this is going to give me a different view of things. I've got a lot, you know, I've got NAs wherever there was a country in our CO2 data that had a CO2 value but didn't have anything else. So this makes it look like, you know, there's quite a few NAs across all these columns whenever our Gapminder data did not have countries like this. So this is, you know, there's a lot of things that you can think about here, like why isn't American Samoa in the Gapminder database? Or why isn't Aruba? Why isn't Armenia? Did this not work properly? And I think that's something that we're not going to get into today. You know, this would be the beginnings of your analysis to understand, like, maybe American Samoa is in one of these data frames as like Samoa, comma, American or something. Like maybe there's a reason, just like word-wise, why they couldn't identify each other. Or maybe there wasn't data for a country, and so it wasn't included in the list. Or, you know, you can sort of work backwards depending on what you're trying to do with the data and like what you know about the data. But being able to join these data frames is pretty powerful.